are you? So today we would be doing the fifth question from worksheet number 2, database questions, IB. Let's see what's there in the question. And the question says that an array of photovoltaic cell is used to provide electrical energy for a house. When the array produces more power than it is consumed in the house, excess power is fed back into the mains electrical supply for use by other consumers. The graph shows how the power P produced by the array varies with time of the day. The error bar shows the uncertainty in the power supplied. The uncertainty in the time is too small to be shown. Okay, so the first A part says using the graph, estimate the time of day at which the array begins to generate energy. So first of all, like you must be knowing that like photovoltaic cells are there, like sun goes off there when there is sunlight and it start producing the energy. So this is the graph at the time of day. We have noted that how much energy we are getting. So let's see now. For this first A part, we need to draw a graph that would be joining all these points. So let's join this. So like this, it would be joined. You can join it better when you would be having some paper and pencil. So the first A part would be 8 a.m. So we can have a little bit of plus or minus, like for the one box. So the reading of one box is like this is 10. So it would be like 60 minutes. So plus minus of 6 minutes, you can say. So this could be the right answer here for A part. For the next part, the average power consumed in the house between 8 to 12 is 2 kilowatt. Determine energy supplied by the array to the main electrical supply between 8 to 12. So we know that average power is 2 kilowatts. So you can write like this, like average power is 2 kilowatts. So for how much, what is the total time? From 8 to 12, it is 4 hours, like 1, 2, 3, 4. So for 4 hours, we got average this. So time is 4 hours. So the total power here is average power is 8, not 8, 2. So the average power was 2. So this is total 8 kilowatts. So 8 kilowatts is the total power consumed during that. But we need to calculate that how much energy supplied. So this will be known to us if we know the area under the curve. So for that, we need to calculate the area under the graph. So we can make like this would be the first triangle. Like there would be two methods. One would be like getting the curve, then doing the integration, that is the calculus part, that would be done if you are in C level. But for this level, we would be using a simple method of geometry. For that, we can like if we join this, it will be a triangle. If we join like this, it will become a triangle. So for that triangle, first of all, I'll just draw all the figures so you know it better. So like from here, so this will be one, this will be another, and you can elongate them like this. We can make a set of two to each to reduce the calculations. See, what I am doing is I have just drawn straight lines. So what figure you would be now having it? See, these would be, these are the figures. Okay, So basically we have drawn like this, so we will calculate the area of each segments. So for the first, we will see that how much would be the area. So for that, first we need to see the points here. Now this is half because this is 830, this will be 930, this will be 1030, and this will be 1130. How? Because the total 10 boxes for one, and it would be like this will be the midpoint, it would be 730. So these are the midpoints, like 5 boxes here and 5 boxes there. So for this point would be like here. So this will be like, how much is the one box? This is 1 by 5. So 1 by 5 is 0.2. So it would be like 1, 2, and 3. So we can take it like 1.5. And this point would be like this. So it would have be 2.4. And this point would be like here. Yeah. So it could be 3.2. So now this point, so this point would be here. So it can be 4.4. Is I'm right? I need to little bit maximize it, or it would be okay because it would be within the error mark. So this point would be like this. So it would be 5.8, and this would be 6. So now we need to calculate the area. If you don't know the area formula, I will tell you, like for trapezium, first we take the average. If like this is y1, this is y2, it will become y1 plus y2 upon 2 into this x value. So this is the formula for trapezium, and this is first of all we will calculate the area of a triangle. So I'll do a little quick. So let's see. First of all, you see that this is half, and half into 2 into the height. So it would be like 0.5 into half into half again, because it would be like 1 by 2 into the altitude and the base, that is the area of a triangle, into, so this height is 1.5. So this is 0.375. So I'll write here 0.375. So this is the first area that we got. Now the second area would be like this point and this point, the average of this point. So this is 3.2, and this is like 3.2 plus 1.5, this, and average we will divide it with 2, equal to 2.3. And if you will multiply this with this, it will be 1. 930 minus 830 is 1, so it will be 2.35. Okay, because this is all 1, so we will just calculate the average of y into the this distance, and this distance being 1, it will not make any changes, but it will make changes at the last. So now we need to calculate for this portion. So this portion would be okay. So this will be 4.4, and this is 3.2. So 4.4 plus 3.2, total this divided by 2, 3.8. So when 3.8 will be multiplied with 1, it will be 3.8. So this is 3.8. Now we will do this, or like this will be like 5.8 plus how much? Have we taken this point? Yeah, this point will be like 4.4 or 4.5, 4.6 you can take if we are not wrong in it. So it will be 6 plus This will be 14, 10, 10.4, then divided by 2, it would be 5.2. Let's do with the calculator also. Okay, 5.8 plus 4.6 divided by 2. This, and when multiplied with 1, it will be 5.2. So 5.2. Okay, so for this I have taken like 4.6. You can take here also, but in the mean it would be okay. Then it would be this point. This point is 5.8, and 5.8 plus 6 would be 11.8 divided by 2. For this, we will not multiply with 1 because this is only half. So we will multiply it with 0.5. So this is 2.9. 2.95. So this is the method how we have to calculate the area. So we will now add up all the segments. 0.35 plus 3.8 plus 5.2 plus 2.95. So this is 14.67. So the area, that area is 14.67. So here the area is 14.67, that is kilowatt hour. So this much of energy has been provided by the grid, and then this much is used. So 14.67 minus 8 would be the right answer. So how much it would be? Minus of 8. That is 6.67. 6.675 kilowatts per hour. So to convert this to joules, we need to multiply with 366. That is the number of seconds, and that would be, so it would be required like this, to 6.675 into 10 raised to power 3 into 3600. So we got 24030 into 10 raised to power 3. So we can have a point here. So this will be 24.03 megajoules, because mega is 10 raised to power 6 joules. So this is how you have to solve the B part. Now let's see what's there in the C. The power P produced by the array is calculated from the generated EMF V and fixed resistance of array using this equation. The uncertainty of R is given to us. So it says that power is equals to V square by R, and we need to calculate the percentage error of V. So first of all, we know that delta P by P will be 2 delta V by V plus delta R by R. So we need to calculate delta V, the percentage of uncertainty. So it would be delta P by P minus of delta R by R equals to 2 delta V by V, and this 2 will go downwards and we can cut off this. So this is what we need to calculate. Then we can multiply with 100 to get the percentage. For that R we already know that is 2%, and delta P we need to calculate. So delta P at 12 o'clock. So now you see this. For this we need to calculate. So I'll just eliminate this so you can have a better picture over there. So now see 1 and 2. Two boxes is there, and one box is 0.2. So this is 0.4. So 0.4 is the uncertainty of, okay, we were here. So 0.4 is the uncertainty of power at 12 a.m. So we will use like 0.4 is the uncertainty of the power divided by the power value is 6. The power value would be 5.8 we can take. Yes, for 5.8 minus of 0.02 because it is already given to us as 2%. So then divided by 2 into 100. So this will be delta V by V. So let's see whether we were right or not. Let's calculate it first. So 0.4 divided by 5.8 will be this much minus of 0.02, this divided by 2, okay, into 100. So this is 2.44. So it is 2.44%. So this is the right answer. So uncertainty value is calculate the percentage uncertainty of V. So percentage of uncertainty at V is 2.44%. Now let's do the next part. Later that day, a second set of data was collected starting at 0 t equal to 0 and the variation of p square with t time since the start of his second data collection is shown in the graph. This is a graph using the graph determine the relationship. So basically we need to calculate the graph equation, that is y equals to mx plus c. So this point would be like this one box is off, like this is 50 and these are 10 boxes, like these are 1 2 3 4 5 6 7 8 9 10. So like 50 divided by 10, this is 5, and this here this box is like 1 divided by how much, 1 2 3 4 5. So similarly 0.2. So this would be 220, not 220, 210. So it is 210 because this one box is 5 and other box is 5. So 210 comma 0, and this will be 0 comma, so it will be here. Let me for a little bit maximize it. Yeah, now the picture is more clearer. Okay, so now we are in between of this. So from 1 to 3 with 3 box means 8.6 and this is half, so 8.7 we are here. So now again zoom out. So now we will be calculating the values of C. See, if x will be 0, the C is 8.7 because this is the constant value where x equals to 0. So now we need to calculate the value of M. So M value will be like 0 minus of 8.7 divided by 210 minus of minus 1 minus 0. Okay, you know it, like these are the 2 points and I am just calculating the slope. Slope is, the formula of slope is y2 minus y1 upon x2 minus x1. So that's why I didn't give you formula directly, I'm doing it. So it would be 8.7 divided by 210. It is 0.041. 0.041, that is negative. So what will be the value of y? So y will be not y equal to mx plus c. This equation will be changed to p square because y is p square and m is the negative of 0.2. 0.041. X is the time t plus 8.7. That's it. So we can say that p square equals to 8.7 minus 0.041 t. So this will be the right answer for that. This is how you have to solve it. Let me see, everything is right. Yeah, so everything is right here. Hope you understood this question very well, and if you still have some doubt you can put it in the comment section, or we can have one-on-one classes if you ever require that. Thank you for being here. Thank you for watching the video.